Let's answer a couple of questions that we've prepared, and then we'll open the floor up to general questions. So first off, can you all introduce yourselves?
Hello, I'm Ofir. Ooh, this is loud. I've been working on benchmarks for like 3 or 4 years. I was one of the co-authors of SweBench, Psycode, I don't know, a bunch of stuff. And I'm very excited to be here.
Okay. Yeah, hey everyone. It's such a big call. But yeah, my name is Xiang Yue. I'm an assistant professor at NYU and also like research scientist at Google Deepmind. I also build like different benchmarks, mostly in multimodal understanding. For example, VStar bench, VSI bench, CV bench. Some of this has been used in the frontier multimodal.
Hi, I'm David. I am a researcher at METR, Model Evaluation and Threat Research. Previously I was a researcher at NYU for a couple of years where I made GPQA. Yeah, more recently I've been working on kind of software agent evaluations and benchmarking.
Hi, my name is Eve. I'm at UC Berkeley. I work broadly on evaluating LLMs, particularly for societal impacts, and thinking about how we can learn from people who disagree, so the directions that have since been known as annotator disagreement or pluralistic alignment.
Hello, everyone. My name is Wenda. I'm a research scientist at Google Deepmind, and I work heavily on the learned evaluation metric and dynamic benchmarking.
All right, great. So the reason I'm standing up here is so I can progress to our question slides. So what we'll do is we'll go through 2 of the questions we've prepared, and then we'll open it up to audience questions. So the first question I want to ask is this. The theme is tyranny of metrics. So the things we're capable of measuring shape the way that we design our evaluations. My question for the panel is broadly, how have the limitations of metrics shaped your own research projects? What things can't be measured right now that you would like to change, and why?
Yeah, I can start. I think one big kind of challenge in benchmarking that I see is having kind of multi-agent systems, or how for example, language models interact with people, or very non-deterministic systems seems really hard. Or I feel like I don't really know what the right way of doing this is. I'd be curious if panelists have thoughts on how to do this well. I guess the challenge is the core challenge I see with this is you don't know whether some change in performance is because of the other kind of non-deterministic system, or if it's because of some change in your language model or your scaffolding or whatever. I think this makes it really hard to benchmark how models interact with people, which seems important broadly.
Yeah. I think one of the biggest challenges in building a good metric is actually understand how robust your metric is. No matter how much you try in building the best metric that correlate with human, there are often those tiny honey spot in the metric. You can always hack those metrics through it. So nowadays, we not only just leveraging those metrics to visualize the performance of the model. Oftentimes, we kind of treat them as reward model as well to be part of the training. So we have to be extremely careful of how many honey spots those metrics are. Are those improvements on the metric really meaningful? Those are not reflecting in the current way of our meta evaluation of the metric. For example, Pearson, Kendall correlation, they do not capture this. So how do we know those honey spots in the metric, how to expose them, how to quantify them, and how do you know the improvement of your model is really meaningful rather than just reward hacking? That's a quite challenge.
Yeah. A central challenge that I think about a lot is the difficulty of operationalizing very fundamental but very subjective issues we talk about. So if we say things like, oh, let's incorporate human values, like what does that even mean, right? And I think these can be especially challenging because oftentimes we can get agreement in the abstract. Like if you ask people, let's make the model fair and just, everyone thinks the model should be fair and just. But you give them 100 examples of particular behaviors, and you get 100 different responses on what that should look like, right? And so we have a very fundamental disconnect between the sort of abstract values that we want to measure and how well we're actually able to operationalize them in practice. It seems to me that efforts that have worked better in this direction have looked not just at opinions, but at like downstream impacts, right? So like what happens if you do a particular intervention? Are people better off? These sort of more downstream focused views seem to be a better way to evaluate this sort of thing.
Sure. Am I the only one who's from a multimodal computer vision background? Yeah, so I think before 2021, the entire field of computer vision is based on carefully designed metrics, right? Like, starting from ImageNet, 1,000 plus classification, and for co-code object detection, have like this really complex but really, scientifically rigorous metrics that people design. I think this really leads to a lot of progress in computer vision. But then after 2021, entering this multimodal era, I think we're like looking at much more diverse, metrics, partly induced by this more general, more real-world VQA settings, right? This is a great thing for computer vision for multimodal models because you are not really confined to this kind of narrowly defined metrics anymore. You are really getting to the real world and solving more diverse problems. But then, as a consequence, the challenge that we are facing is now you have this language shortcut, this risk of just taking the shortcut of language while not looking at real data at all. This becomes the main challenge. So to me, I think talking about iterative metrics, I think this is once you get into the multimodal setting, nothing is clean, and we have to be really, really careful about designing the metrics so we know what we are actually measuring.
I'm going to talk about coding benchmarks because that's what I spend most of my time thinking of. But this question is the biggest question in benchmarking, I feel like. Usually when we propose a new benchmark, it's because we figured out how to measure something that we thought was not measurable before. And so figuring out how to do this stuff is 90% of my job. I can give you one concrete example. I think that building a coding benchmark that would look at how good you are at refactoring would be a really good thing to do. You can go steal this idea. I don't know how to do it. I don't know how to measure if you've refactored a code base well or not. There's all these cyclomatic complexity, there's all these measurements, but all of them are very hackable. I could even ask you to hey, rewrite this thing, but use less lines of code. Or I can track how long your code base is, but they're all super hackable, and agents just start reward hacking when they're given these very simple benchmarks. So yeah, understanding what we can and can't measure and figuring out new ways to measure things that we thought were unmeasurable before is that is the work when you're building a benchmark.
Yeah, that's a really interesting example. Yeah, sorry I'm standing over here. I think I'll do something better for the next. Yeah, I think that refactoring code idea is so interesting because you have these, tying back into the rubric problem, you have various desiderata that can almost be conflicting. Did you overwhelm the maintainers with a long commit message? Or, did you give enough detail to explain what you did? And, did you go for sort of the competing wants that people have in code of did you make it concise or did you make it self-documenting? Did you make it clever or did you make it extensible? There's definitely a lot to think about there. And even just introducing in this work, we propose a metric for the trade-off between conciseness and, extensibility in code. That on its own would be a contribution where I think a lot of people should think about just publishing papers on metrics in and of themselves, because those can actually be very impactful and picked up by people who are developing benchmarks due to this tyranny issue. I don't know. Does that spark anything else, or do you guys want to move on? Alrighty, cool. So moving on, the next question here is about longevity. So why have some evals stood the test of time? Have the ones that have stood the test of time deserved to? What indicates to you that something is likely to last? Don't be afraid to give hot takes.
I mean, this is kind of a joke answer, but I mean, to me, maybe one of the biggest things that like determines if a benchmark is going to last a long time is like, you know, how much do people care about it? And if people care about it, it's like not going to last very long because, you know, yeah, we do have like very, you know, powerful methods now for kind of, yeah, you know, given some new benchmark or way of measuring performance, you know, getting models to be able to perform well. I mean, maybe, yeah, probably this is like, you know, domain specific to a large extent. You know, I think there are domains where we've seen less progress, but yeah, I don't know. I think I'm overall like, I'm like, if the goal of making a benchmark is for it to like last for a very long time, I'm like, I think that's not a good goal or something. Yeah.
I guess to build off that, that is a very interesting response that it's like, I don't care if it lasts a long time because then it didn't capture something that was changing. Yeah. And I would point everyone to check out David's talk from Column last year about how GPQA was, by the time they got to present it at Column, isn't that right? It was already saturated. And then you gave a really interesting talk about like what you can do with resources that's saturated. Does anyone have anything else about longevity, or should I?
All benchmarks get saturated at some point. You shouldn't try to think about something that will last 5 years or 10 years because it's never going to happen. And it's totally fine. With SweBench specifically, the team of John, Carlos, Killian, and I, we've continued updating it for more than 2 years, and I think that's contributed a lot to it still being kind of something that people talk about. So we had SweBench, and then we did SweBench multimodal and SweBench multilingual, so we have all these different variants. And then it was really hard to run when we first released it. And then with external partners and also just our core group of the SweBench contributors, we've just kept on improving it and making it easier to use and run, so I think that also helps.
I just want to add one thing, at least again from a vision standpoint. I think ImageNet is probably the only thing that's do the test of time. While you can see many good things about ImageNet, but I think one thing that's really unique about ImageNet is it's like not just like serving this only purpose of doing like examining the image classification performance, right? People use it for like maybe, you know, diffusion models as well, right? And class condition diffusion models using the image labels. And then for clip model, right, it's also kind of a good benchmark for zero-shot kind of classification. So I don't know, I feel like those benchmarks that has this kind of like multiple dimensions that can support different type of tasks, that could be a good kind of like a property, yeah.
Yeah, I saw recently. I haven't read the paper closely, but yeah, some folks took GPQA and kind of yeah turned it into like a free response benchmark. And you know, there are challenges with doing this, of course, which is you know why we made it multiple choice initially. But you know, I do think there are kinds of things you can do to kind of keep a lot of the value around and still have some kind of comparability. I mean, I think this is like one of the main challenges I feel like benchmarking faces is like so much of the value of a benchmark comes from the fact that it's static, right? Because that lets you compare easily and directly, you know, different systems over time or in different ways. But then what happens when you find issues or models saturated? So yeah, I do like the idea of taking existing benchmarks and modifying them in certain ways, or like still using a lot of the value.
Maybe a slightly different perspective, but I think something that we don't talk about as much as the community, and we may want to more, is benchmarks that stick around like long past the end of their usefulness for a variety of reasons that are not very scientific. You know, like look at a paper and I'm like, gee, you know, I saw a paper 5 years ago saying this benchmark was like just really had no measurement validity whatsoever, but it turned up in a lot of papers, so it keeps turning up in a lot of papers, right? We continue to do evaluations on benchmarks that we already know are not very good, or you know have already been saturated to the point where they're useful. And so I think as a community we might want to reflect a little bit on like how do we, you know, kind of say like, okay, you know, we can wheel this one away now. We don't need to keep evaluating on this forever.
All right, that's great answers. Okay, so now we'll move to human subjectivity. Do you think we're doing a good job of drawing the line on desiderata to account for divergent human preferences? How could we make the problem of fundamentally divergent human preferences and positionality tractable? How should we account for diverse personal wants in alignment evaluation or evaluation of other capabilities and in other modalities too?
Yes, I can speak to this a bit. Currently, there are two fundamental challenges that I think about a lot with subjectivity, disagreement, and how we incorporate that. The first is that the way that we currently build benchmarks makes it very difficult to capture the range of opinions that are out there. Just in a simple case, you know, typically we get data from crowd workers. Crowd workers are not a representative sample of the entire world population, right? So it's easy to get more data, but it's very hard to get more of the kind of data that we're missing. And you can't, you know, necessarily replace a type of data that you do not have by getting more of the kind of data that you do have. This is actually a very old problem, right? This is the same problem as like Dewey defeats Truman kind of surveys where you can get lots of data from a particular kind of person, but it doesn't give you a sense of what everyone thinks. And so there's this quantity-quality trade-off that I think we're still really not managing very well when it comes to subjectivity. The other question I think about is more of a normative one, right? So if we're shifting away from a notion that everyone agrees and we just have to find what the truth is, and you know, if we take the average of a lot of people, we'll just find the truth, then we need to think of this more of like a process and how we might make that process fair. And here I think a lot about how people who work on like elections or voting theory think about this, right? Even if there's not one ground truth answer that we can get, how do we say like, okay, well, given the opinions that we have, this process for deciding upon an answer is more fair than something else we might have done. So those seem like useful perspectives to take on.
So I think just to add so that this question isn't too awkwardly short, what I kind of had in mind when I wrote this question had to do with what tasks should be considered subjective that maybe typically aren't. So during the, since you guys weren't at the full presentation, and this is an opportunity to reiterate to the audience, we talked a little bit about how diverse, culturally embedded notions of concepts, like for example hate speech, but also culturally divergent ways in which annotators may rate things like entailment. You can think about like linguistic acceptability. People from different speaker communities might disagree. There might not be a lot interesting to say in response to this. Like maybe the question itself is the interesting thing, but I wonder how we can do better about accounting for those things, especially when we try to look at LMs as, well, sorry, I'm just talking about LMs. I suppose this applies to VLMs and image generation as well. When we try to look at these systems as being something universal, how can we account for those sorts of divergent things? And what would you look for? But no one has anything. We can just move on. Or go ahead, yeah.
A while back, I was working on a position paper just on subjective tasks, and I was like, okay, well, we should compare to some like objective tasks. I kept looking for an objective task where there was no disagreement, and every time I thought I had found one, there turned out to be some paper being like, oh, it turns out when we do image classification, people disagree over all sorts of things. Oh, it turns out when we do entailment, people disagree over all sorts of things. So subjectivity turns up everywhere. However, it doesn't always turn up for the same reasons, right? And it seems like there's two very broad classes of subjectivity that turn up. One is people simply have different opinions on this task, right? It's like, is this hate speech or not? That's very, like culturally dependent. And the others are like, the question was kind of vague, and so annotators weren't really sure what people were going for, so there's disagreement on that level. And so there's this like subjectivity from under specification, maybe, and then there's subjectivity from like genuine differences in opinion. It seems like we might want to, minimize the former, minimize subjectivity due to confusion, and maximize the degree to which we capture subjectivity due to differences in opinion.
All right, great. So now what we're going to do is open it up to public questions. So if any of these sorts of thought-provoking things came up to you, if there's anything you want to ask the panel, it would be great to hear from you.
I have a first question for David. What is the answer to question 72 of GCQA? We saw an ad, this is absolutely not relevant, but OpenAI or some company was hiring people to build training data for one of my benchmarks, and we knew that they were building it to kind of get a good score on one of our benchmarks because they had like an example question they wanted their human annotators to, pass, and that was question 38 from SciCode. And we were like, oh, that looks familiar. Sorry, that was just a random story. Yeah, go ahead.
Great discussion so far. I'm looking more on education for people who are actually building these evaluators. Today, if you pick any papers, you see, oh, we picked this LLM judge, this is the prompt, and this is our metric, which I find troubling. From your perspective, if someone is building one of these LLM judges, what would be a set of pristine or framework to make sure that this is the right judge, from your experience?
Yeah. So this is essentially the question about how do we build meta evaluation for the task you want to have. Normally, in most of the cases, because I'm coming from more of the translation background, we usually have human judgments for like design score. And we also take the model score and we just calculate the correlations. So that would be the most standard way. However, this is not a trivial thing because human judgment, there's also not a standard way to collect it. For example, for the question we were addressing before about subjectivity. So there's also a common research question related to this point. How do you design a good human evaluation principle, right? We could have some kind of idea. For example, let's build a human evaluation protocol that's minimize the subjectivity. That could be one thing. So there are two parts of the problem. First, you want to design a good human evaluation protocol that follows some kind of principle. For example, minimize subjectivity. Second is once you collect the human judgment, you want to calculate some kind of meta evaluation here, either certain correlation value or other ways.
Yeah, I guess if I could add one thing. I think one of the main challenges I see with using LLM judges is, you have this clean comparison of okay how correlated are the outputs to humans, but this is conditioned on the input. And so, and often, for example, as models get better, the inputs are changing. Now your LLM judge is reviewing, this very potentially, very different distribution. And so I think it's important to think about okay, what are the ways that this distribution might change, and to try and calibrate your judges or just make sure that it works by looking at how correlated it is with human judgments on the full range of on the full distribution that you're expecting inputs on.
Thank you.
Hi. Yeah, thanks for the discussion about using LLMs in the evaluation. Now I'm curious about the panel's opinion on using LLMs for data generation or benchmark generation that hasn't been touched yet. In particular in this context of, I think it was called curation validity. Yeah, just curious about the opinions here.
So I actually have a recent study just on this automatic benchmark generation. The main idea from my perspective for the task I'm working on, for example, translation, cross-lingual knowledge gap, and all those relevant tasks, the key design principle is to make sure that this benchmark is exposing the model weakness. Like the overall goal in this kind of generation is we want to expose what is lagging behind for the model and to have a clear hill climbing signal. And also at the same time, this is actually quite dangerous if you do this approach naively, because we also had a recent study for this LLM as a benchmark instead of LLM as judge. It has a strong preference for the model for the model who performed generation on this test set. So we actually had a careful study on this. There are situations where you use LLM as test set generator, LLM as judge. If you combine with them, they have a very strong bias. But there's something surprising, like if you even just use LLM as generating this test data, the model also has a strong preference, like bias towards itself, even though you have like an independent metric here. So you have to do it really carefully. You know this is like, this kind of generation actually has a strong bias here. My suggestion here is actually, if you know this kind of generation has a bias, you can bias in a way that you want it, such as like, let's bias this benchmark generation to expose model weakness. Then at least in the end, you can have a clear hill climbing signal in this case.
So I have one. One advantage about using LMs to generate samples is that you can realize dynamic benchmarks as simulation environments in interaction with other agents or like end users. So there's a lot of interesting work on user simulation and qualifying that in different ways. So people are working on, for example, for evaluating psychological health of LM users, creating simulators that try to break against the guardrails that are supposed to be there for maybe users talking about self-harm or something, and using LMs to produce those sorts of outputs. And the research questions that exist there are really interesting, where it's things like, once again, first off, how do you meta-evaluate those judges? Like, how do you know you're being faithful to a human? And how can you demonstrate that this is valid? And then also, what are the best techniques? How do you get stability of a persona in an LM over time? How long can you preserve that in context? A lot of interesting stuff there. So I think if you want to look into LM generated data for benchmarks, I think not just thinking about how do you augment the static data we have, that's very 2022 in my opinion. Thinking about like how do we generate, how do we make a living dynamic and environment within which the model you're testing is interacting. That's really the exciting place for LM generated data in benchmarking in my opinion.
In my very limited domain of programming, it's basically impossible for language models to generate good questions, so we don't really do that. We have this new benchmark, which I think we put out last week. It's called Critical Point, and every question there was written by like 3 physics PhDs and reviewed by like a bunch of other people, and it took a lot of manual labor to find questions that language models can't answer, so it's just not even something we can even conceive of language models being able to write good questions.
See, one thing, we have this paper called, Live Code Bench Pro, which is about like competitive programming. I agree, like for this complex situations, I think cannot work. We have this follow-up paper called Autocoder, which is basically, coming up with this new competitive programming exercises for the model. And of course, you need to do a lot of filtering. In the end, like maybe only 3% will be kind of useful. But still, you can, automate the whole system and get a lot of this kind of competitive programming, kind of questions to test like reasoning capability. So it's a different scenario, but at least their LMs helpful.
So historically, many ML benchmarks have been focused on things like model comparisons or method development, but increasingly we people want to build evaluations that are able to inform external decisions around deployment or safeguards. And I'm wondering, what do you think are some of the key shortcomings or challenges for that category of evaluation that aspires to inform potentially high-stakes decisions?
Yeah, I mean, one of the biggest challenges is just validity. Just does the benchmark capture, really capture the thing you care about? I think typically, I mean, like, it's almost taken, I think, as just like a baseline that, in the field, I think that, like, benchmarks are proxies. They're like, they're this, efficient way of measuring something that we hope is like pretty correlated with what we actually care about. But yeah, I think it just puts like way more pressure. If you have, some really important decision on the validity of the benchmark, and I don't know. I think that can. I'm not sure about the trade-offs here, or like one alternative, for example, to benchmarks. There are other types of evaluation. So, you can just run an experiment where you give people access to the tool and, see what happens depending on, the question you're interested in. And, you don't get the really nice amortization there, right? You have to, spend a lot of money and time and effort, each time you do it. But you have a lot more confidence in the validity of the measurement compared to a benchmark where the goal is, to be able to easily run it a bunch of times. And I think that's why, benchmarks are, really useful for model development, where you need to, do a bunch of iteration and try a bunch of different ideas. And you can't run, a randomized controlled trial every time. But I do kind of imagine, that a lot more like kind of individual like effort, should go into high stakes decisions. Especially if you're only making them like, I don't know, once a year or something, if you're a big lab or whatever.
Actually, this is a very good question, because as an industry perspective, I think, as David already mentioned, like, you have to be careful when you're making this deployment decision. Like, is there any distributional change between the data you actually perceive in the production or the data you actually benchmark on? Many times, we often only testing model in academic benchmark, which is clean, nice data. But sometimes when you actually look at the user log, the prompt you receive, it's completely, even grammatically incorrect. And even with those prompts, you still expect model to do pretty well as well, right? So if you only use like clean public benchmark to benchmark on your model and create such like LLM as judge only working pretty well, has high correlation on those prompt set, it's pretty dangerous. So you always need to make sure, like, before you make a launch decision, like whether you really studied like user log data, whether your LMS judge is even robust on those like out of distribution user data. I think those are really important decisions to make.
All right, so we have a question from within the panel, and then we'll go back to audience questions. What is one mistake that you see benchmark creators make? What is the biggest mistake that you see benchmark creators make? And call them out. No, I'm kidding. Don't call them out. Do you want to go first, Ofir?
Sure. I have like 3 things. I don't know if I'm allowed. The biggest one, what's the biggest one? Okay, I'll go for the biggest one, and I'll say 2 smaller ones. I think the biggest one is launching a benchmark with the top model achieving like 70 or 80% accuracy. I think, so typically, anything that's above like 15%, it means that the model developers are aware of this kind of dimension in model capabilities, and they're actively working to kind of get to like 90 or 100%. And so if you're working really hard and you're putting out a benchmark and it's already at 30% accuracy, it's kind of like coming up to me and telling me I have 2 arms. Like, I know. Like, tell me something I don't know. Like, why don't you try to find something that's like 0% accuracy or 1% accuracy? Like show me something I haven't even thought of. So sometimes I'll be just randomly reading papers on arXiv and I'll see a new benchmark out that's like, you know, GPT 4 or 5 gets like 70% accuracy, and I'm like, dude, come on, like you guys spent so much time, so much human effort, but this is something that's already basically solved. It's going to be solved in the next generation. Like, so yeah, we spend a lot of time just trying to find things that are like 0% accuracy. I think that's the way to kind of show people, hey, there's this thing that we think is a natural, interesting thing to work on, and nobody's working on it right now. Let's put a spotlight on it. Let's try iterating on it. Let's work on it. I think that's where we can have the most value in building benchmarks.
All right, a quick comment on the multimodal side again. So I think, you know, people know, right, like the biggest problem is to answer these questions for this multimodal benchmarks, you don't need any visual signal. You don't need images or videos at all. This is nothing new. People know about this like maybe 8, 9 years ago when they built the first kind of VQA benchmark. But still, this is the biggest problem for the existing benchmark, for all the new benchmarks as well. Right? So we have like this recent study. So one thing that we really want to advocate is if you are a benchmark builder, you should really kind of stress test your own benchmark by maybe training on your test set, right? Like by that I mean like you can take the language part, you can have like this question answer pairs. Forget about your image, just like train on this question and answer pairs. If you can get like really high performance, that means like, you know, okay, your benchmark is purely kind of knowledge driven. It's nothing to do with like the multi-model signals. And then you probably need to like maybe do some filtering and just do something about it. Again, this is kind of like some kind of crisis right now in the multi-model community. People know about it, but still I think people still haven't paid enough attention to it.
Yeah, I'll take some shots here. I guess. So I think sometimes I feel like I'm not seeing this as much as it used to be the case, but I feel like some benchmarks. I think ArcAGI is like a good example of this. Or like they come from kind of a particular model, like very specific narrow model that you know the designer has of intelligence or kind of general capabilities, and I think this is like maybe they're right, you know, maybe you happen to be right, and you know you've got the idea or whatever, but I think in most cases, or like it's really hard to just like think of, you know, oh, what is intelligence, and here are the criteria, and so yeah, I guess I don't find benchmarks in that genre or style to be nearly as informative or meaningful. It's like, okay, you know, model can do, you know, people have, you know, these certain, like, you know, visual, spatial skills, pattern recognition, whatever. You know, there's some connection between those skills and our general intelligence. We don't know what that connection is. Ultimately, you know, nobody terminally cares about how well models do on, you know, on this task. What we care about is, you know, how they perform in the world. What are their kind of capabilities in relevant things that we care about. And so I don't know. Yeah, I think these like highly kind of model driven or like theory driven benchmarks seem less useful to me generally.
Switching gears a bit, I guess there's 3 like rapid fire things I see over and over again when the benchmark involves human evaluation or human labels or something. And they seem like really dumb, low-level things, but they constantly happen and they really destroy the validity. The first is failing to properly filter your data ahead of time. So just being like, we put this on prolific and then we got responses, and then we took out a couple that seemed bad. These platforms have so much spam, especially if you switch to things like METR, the spam rates can go upwards of 25%. That really needs to be filtered ahead of time, or the labels are practically random. The other one I see is failing to cap the responses if you're trying to get a good distribution of a population. If you just put one of these surveys up on a platform, you'll get a Zipf-ian distribution of responses. You are not measuring the opinions of the population, you're measuring the opinions of Bob, right? Because Bob did 80% of your annotations. And the last one I see is doing human model comparisons that really fail to account for like who the humans are. In particular, if you get like a random sampler of crowd workers to do something on a task versus people who have some domain expertise versus the very best experts, you'll get a completely different, result for like, oh, do models beat humans on this task? On one study I did, we were looking at only expert annotators, and even there, the comparisons between humans and models were very different depending on who you chose. So.
Yeah, I think everybody is very comprehensive. I just want to add two simple things. So for the paper who only say we include X, Y, Z without a statistical significance, that's not great. And for the benchmark who choose a random sample size without confidence interval, or performance improvement in the training without confidence interval are not that great.
Okay, very short, and I want to make this measured. Giving the model a test for a human, and then assuming it can operate in that domain well. I do think tests for humans are very valuable. Like, I really like GPQA, but I think we have to be measured in what high scores on those mean. So I think it is an important component of intelligence to be able to answer those questions. But I think it may be a necessary, sufficient conflation going on, where it's like being able to do that is definitely necessary to be able to operate, but it probably isn't sufficient.
I just have a tiny, small distillation of what David said. I totally agree with everything he said, and my word to kind of try to describe the property that he was describing is building benchmarks that are natural or useful. Like when I build a benchmark, I try to think, okay, if we have this, and we have a model that does well on this, is that going to be useful for us, right? And if we get really high scores on SweBench, that's going to be useful probably. But if we do really well on IQ testing, I'm not really sure what population of the world that's going to help. So that's kind of something I try to keep in mind.
Awesome. Okay, so since they started us a little late, I'm going to be a little naughty and try to get us a few extra minutes after, but we'll see what happens. So, another question?
Yeah, thank you for the extra time, and thank you to all the panelists for the interesting discussion so far. So it seems we are really at a golden age of benchmarking. Everyone here in the room, everybody in the field appreciates the value of good benchmarks. My question is, will this golden age end, and will it end soon? And the reason for this question is, we're running out of experts in many domains. You mentioned 3 physicists, PhD students, or post-PhD experts having to grade a single question. That's a state where we are at in many domains, right? We may have some domains with verifiable rewards, so those probably will be fine, right? But most interestingly, the refactoring question plays out in other fields as well, right? For example, judging whether an idea is scientifically novel is a very difficult task. Right? And so the question is really, will it end? How will it end? Or am I just a bit too pessimistic?
So I think part of why we're in a golden age is that benchmarks are very easy minimum publishable units to push out. So there's a lot of benchmark papers. There's different levels of quality. And that's a self-owned as much as it is a own of everyone else. So.
Yeah, I think it's like, there are 2 things I'll say. So the first is, I think there's just a classic like Moravec's paradox thing in terms of like expertise, and with like reasoning models in particular. I think that people in like 2020, we had kind of bad language models. And we were like, can they reason? Like, oh, reasoning's so hard. And then, well, it turns out, okay, actually reasoning isn't as hard. If you compare, model performance on SweBench or GPQA to their performance on like actual computer use, like control tasks that involve kind of sensing and like low-level manipulation, like performance is still quite low on these other benchmarks. And so I think that there's just a question of like what are you measuring and what do you care about? I guess in terms of like, yeah, separate from that, I do think benchmarking is going to get harder. I think probably focusing on like other aspects of performance, like efficiency or reliability, I think is something that benchmarks haven't focused like a ton on. But models often will be answer correctly like 80% of the time, and that's like about 80 or 90% of the time, and that's about where kind of performance taps out. But sometimes you need like 99.9% reliability, and that's really hard. And I don't think we really have figured out how to measure this well. So I think there are like directions, but yeah, I do think it's getting harder in a lot of ways.
Okay, one more question.
Okay, so this is more of a comment on subjectivity, and I think this will add substance to our discussion. Perhaps this is more directed towards Eve's research than others. I'll cite this theory that modern psychology, the discipline of psychology, actually made our minds less diverse, in the sense that once we have a theory for how the mind works, most people are indifferent to how they choose to characterize themselves, so they'll sort of convince themselves that they fit into this mold. And there's this other piece of very interesting statistics where researchers sort of pile together RGB diversity in pictures pre-internet era and post-internet era. And you'd think that internet allowed for more diversity in people's aesthetics, but that actually isn't true. It turns out that pixel, color diversity significantly degraded after the internet boom. And there's this other, various examples throughout intellectual, history, especially in economics, where, before people thought, I can just price this instrument, whatever, but after some researcher came up with a formula, everybody thought that this is the optimal way to do things. So I guess one question that I have on subjectivity is it real, or is it just that we're not yet on the same page? Because if I look at, the development of human intellectual history, there is this strong tendency for us to converge on the same thing. And, whether subjectivity is just, I don't want to use forgive me for a lack of vocabulary, but an illusion that, perhaps you're not seeing things.
That's a great question. What do you think, Eve?
Okay, well, I think you've hit on a very profound point. I'm gonna go out on a limb here and say that I think subjectivity is real. I think people actually disagree on stuff. Hot take. But I think the point you've hit on, which I think is very crucial, is when you have a shared tool or a shared model or a shared way of understanding among a community, however large it is, you get convergence in opinions as people start using that, right? You invent psychology, people start framing their own experiences in terms of that shared model of psychology. You invent the scientific method, people start framing their research in terms of scientific method. And so I think the responses to that are not so much on the end of how do we incorporate subjectivity into a model. I think that's a separate question. I think it's more along how do we encourage a diverse range of models. And that, I think, is more a question of like who has access to create these tools, how do we create a different range of tools, how do we make sure that it's like not everyone in the world has to use ChatGPT or something like that. And I think the places where I've seen the promising work on that are things like local communities making their own models, making their own like repositories of data and that sort of thing, so that there are basically different epistemological frameworks, right, that can be created by different people having the power and access to create these tools.
Okay, one sentence question. Can you get it down to, it can be a little long, but.
Okay, I will make this quick. So how scalable do you think is the current metrics and benchmarks towards like the ASI age? Like when AI gets to superhuman performance, how do you make sure your benchmarks and metrics can keep up to that?
Yeah, I mean, one thing is like, you know, if you have questions that like people agree on the answers to, and you know your AIs are getting wrong, then you know there you go. That's done. I think like ultimately we care about using AI systems to do things we want, and we need to be able to evaluate that. And so if models are like doing things that we just can't understand at all, for instance, I'm not going to trust that system. Even if there's some argument or whatever, for I want to be able to directly see and evaluate whether it's doing what I want. And so I guess I view this mostly as like our evaluation metrics kind of become like more and more abstract over time and more like meaningful and kind of higher level. So I could imagine speculating wildly, like the evaluation is just like have I been have I had a good life over the past like year or something, or like does this city broadly that our AI our incredibly powerful AI system has been designing, does it seem to be thriving? If you go there, are all the people happy and like are good things happening? Is it whatever? I imagine like those becoming the kinds of metrics that we end up using.
Thank you.
Okay, we're going to do another Ofir question. We'll start there and then we'll go here. What future benchmarks are you excited about for the next year? So you can't think 10 years in the future, for the next year. Benchmark a capability that doesn't exist yet, that you think is within reach.
Okay. Yeah, I'm actually more interested into a concept rather than like a concrete benchmark. So I believe in the future is a future of dynamic benchmarking. It's actually relevant to the previous question, like what will happen when a model is more intelligent than us. We can use model to create those benchmarks, and we can use them to evaluate. And all we can rely on is some simple heuristic, like based on all the information I had, like is this, are we able to know if it's correct, something like this. So what I'm most excited about is like how do we let model take over to create a benchmark, create this LMS judge, and we just do minimum work that can ensure the correctness of this whole process.
I'm most excited about like longitudinal impacts research. We're finally at the point where people have been using LLMs long term. What happens to those people, right? Are there effects on their well-being, positive or negative? Are there disparate effects across the population? We're starting to see some studies on particular effects or particular populations. I think like a larger scale longitudinal effort seems within reach at this point.
Yeah, this is kind of a random like personal interest or something. I'm like I still feel like language models in particular are like quite poorly calibrated, and I feel very confused about why this is still the case. I'd be interested in just generally evaluations that that measure when do models know what they know, when do they know when they need to search something or use a different tool, or ask a person for more clarification or whatever.
Yeah, I personally will be more excited about like benchmarks not built by PhD students and experts, but like kind of rediscovering those skills that's about like human level intelligence or even cat level intelligence that we can took for granted. We started this type of like exploration with like spatial reasoning, things that's really, really simple, right? Like every human can do. But like the current model, LLM-based systems, completely fails. I think there will be a lot of cases like this.
I don't really have a good answer, because if I did, I'd just write the paper. When I joined Princeton a bit more than 2 years ago, human eval was like the craziest, hardest programming benchmark, and we thought there was no way we'd be able to do something that was hard, and then we did SweBench, and now I think it's time for another step of that magnitude, something that makes SweBench look extremely easy. So that's something that I spend a lot of time thinking about. You know, we've gone into like 80 something on SweBench, but we have not replaced 80% of a programmer's day. There's a huge gap between what our benchmarks formalize and what humans actually need to do day to day, and so I'm excited to narrow more of that gap.
Great, thank you. All right, they're giving us the cane. Thank you, Tesla. Sorry, it took 5 minutes. We lost some at the beginning. All right, thank you, everyone.
Thank you.